Okay, good evening, everyone. Welcome to the demo session of Embedded Automotive Testing course. Today we will go through the what actually this course is all about, and what are we gonna learn in this course. What are the future opportunities for this course? I mean, kind of A to Z details about this course. Fine. So, what can anyone tell me? What did anyone hear about this term called as Embedded Automotive Testing?
Yes.
Okay, let's break down into different parts. What do we mean by an embedded system?
It's a combination of software and hardware.
Perfect. It's a combination of a hardware and a software. So, what do we mean by a combination of a software and hardware? For example, if we want a machine to do our work, let's take a washing machine. What does washing machine does? It will replace the manual effort of washing the clothes, right? So there is no human intervention needed. When we put the clothes in the washing machine, it will run automatically and it will clean the clothes. Okay. So now, can I take this as a classic example of a embedded system? Can I consider a washing machine as a classic example of an embedded system? Yes or no?
Yes.
Yes.
Why? Why? Why we can consider washing machine as an embedded system? What quality it has?
It works automatically, not use humans and something.
Okay, when there is no human intervention, that we call it as an automation. Right, when the system itself runs every task, that we call it as an automation. But why do we consider it as an embedded system first? As we discussed previously, embedded system is a combination of a hardware and a software. Let's take the same example of a washing machine where we have a combination of a hardware and a software. So in the washing machine, we have a hardware, correct? We have a washing drum, we have filters, we have water pipes, all those things. And once it is turned on, the entire operation is done based on the software. It is a combination of a hardware and a software, correct? So embedded system can be defined as a combination of a hardware and a software which performs a particular action or which performs a particular task as defined. Whatever we define for the embedded system, that action will be performed in the combination of a hardware and a software. Can you people give me more examples of an embedded systems which we see in our daily to daily life?
ASE.
AC, very good, perfect.
Infotainment, like car infotainment.
Perfect.
Tire pressure monitoring.
Okay. Good. More examples.
Electronics items like
We can consider mobile where we use it daily.
Missiles.
Sorry?
Missiles.
Okay, yes. More. Can you think of more examples like that? We use many things like AC, TV, mobile, washing machines, dishwashers, cars, vehicles, or basically all the vehicles which include software, as you said, missiles, lifts, elevators, escalators. All these comes under the examples of a classic examples of a embedded systems. Correct? Now, let's learn what is embedded automotive testing. What is embedded automotive testing? It is nothing but this embedded automotive testing, as we discussed already about the embedded systems. And let's go to the next one, automotive. What is meant by automotive? What is meant by automotive industry? What is meant by automotive field? Can anyone give the answer?
Vehicles.
Vehicles, exactly. On-road moving vehicles comes under the category or the branch of automotive. Perfect. Now, can you give me the examples of automotive systems? Automotive examples like cars. One is cars, the other one, I mean, more kind of examples. So this see all kind of vehicles like trucks, cars, even two-wheelers in today's world,
All
buses.
sensor vehicles, all like
Yes, all vehicles which has a software embedded into it. It can be in terms of sensor readings, it can be in terms of radars, it can be in terms of any other form of communication. A vehicle which has a software as a part of it, which works along with the hardware, we call it as an embedded automotive system. Do you agree with me?
Yes.
Perfect. So, as mentioned here, the discipline of verifying that the software which is running inside a vehicle electronic control unit, whether it is behaving correctly, whether it is behaving safely, and whether it is behaving as per the expectation of the customer under a real world scenarios, is considered as an automotive testing, embedded automotive testing. What do you mean by the statement? The meaning here is you wanted some software in your car. For example, some of you have told infotainment system, some of you have told tire pressure monitoring system, correct? So for all these things to work out, how you will measure your tire pressure? Tell me. You will have sensors inside the tires. That sensor will give you the readings, and as per the readings, driver will get to know the information whether the tire has low pressure, high pressure, or whatever it is. But when you talk like this, the process is very simple. Sensor will give readings, driver will know. But behind that, there will be lots and lots of mechanism, lots and lots of processes that will be going on for the driver to get a correct and accurate information. Between the sensor reading to the driver information, there are so many processes, there are so many steps that happens in between in order to give the user a correct and an accurate information. So this embedded automotive testing is all about testing the software which is developed for a particular purpose is working in a way that we wanted or not. Exactly how we wanted that software to work, it is working in that way or not, is all about this embedded automotive testing. Why do we need testing first? For anything. Say you bought a new TV for your home. What is your immediate thing once you get it home? Or before you get it home? What do you do? Or mobile, let's take any device. You bought one new mobile. What you will do? What is the first
Whether
thing you
it
do?
works properly or not, we will check.
Exactly. Perfect answer. First, you will check whether it is working as you wanted it or not, or as it is intended to do it, work it or not. Correct? That is what we are terming it as. We are labeling it as testing. Say for 20,000 mobile only, we are doing testing. Imagine when you buy a car for 20 lakhs, where you were expecting all the softwares, like you said, infotainment, tire pressure monitoring, ADAS, so many XYZ features. If you buy a car of 20 lakhs, you need everything to be perfect in it, right? For that perfection to be attained, there are so many engineers which works on the development of software parallelly who tests that particular software. Why testing is needed? Because to ensure that the user has a smooth experience with the software, that the software doesn't have any defects or the software doesn't have any bugs, kind of thing. The testing is very, 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 very important in this embedded automotive field. When you compare it with the other fields, developers has more reliability or more what dependency on the product. But when it comes to the vehicles, testing is very, very major part. Why? Because as here it is mentioned here, where software meets the road and failure is not an option. And I have given you the example as well. See, when software fails, when you're driving a car, you bought a car with worth 20 lakhs or 25 lakhs, and you are driving at 100 km per hour. And when your software fails, if your mobile fails, you will see you bought a mobile, it is not working, or some feature is not working. You will restart the mobile and make it work or something, or you will go into the service shop and you get it repaired or done something, which is not very major. But when you go in a vehicle at 100 km per hour and your automatic brake system doesn't work, what will happen? What will happen?
Entire life at risk.
Yes, entire life is at risk. Here, user is at risk. The customer who bought your vehicle or who bought your software is at risk. So here, testing plays a very, very, very critical role in embedded automotive field. In entire automotive field, testing takes the first stand. No matter how much advanced software you develop, no matter how much advanced design you design for the vehicle, no. How critical testing have been done, how rigorous testing have been done is the whole point here. That is why this embedded automotive field has a very high prominence, especially for the test engineers. Okay, so there are so many important critical features. Let's take an airbags. Airbags runs on a software. When the brake pedal is pressed at a certain speed, suppose let's take 100, 120 or 150, when a sudden brake is applied, your airbag should automatically open. Or when there is a collision detected, right? When there is a collision detected with the other vehicle, immediately your airbag should open. How does this happen? It happens via the software. It happens via the communication between the brakes and the airbags. If that software is not working properly, if the software is not communicating properly to the airbags will not open and the user might die. Correct? So there are so many critical features like this: braking, airbags, steerings, ADAS. So any small malfunction in this functionalities also can lead to a loss of life. Correct. So this is a very, very critical feature. When you see today's car, why this automotive testing has been growing over the years is, you see, I'll take a very small classic example. In 1990s, you have a basic cars like, I don't call them basic cars. You have a cars like Ambassador, Maruti Suzuki, a Maruti Alto, Maruti 800. And today you have so many cars from different manufacturers. Can you spot one major difference how the vehicles have evolved from 90s to the present generation? What is the difference between those generation of vehicles and the current generation of vehicles? It might be design. Okay, I accept you will have more, you had more sleek designs, now you have more colors now. Okay, not in terms of appearance. Other than appearance, what changes,
Safety
what major,
features.
sorry?
Safety features.
Safety features, exactly. More, any other things?
Smooth functioning, smooth running.
Smooth running, perfect. More. any more changes or any more differences you observe from the older generation or from the current generation and from the generation of vehicles? It might be any vehicle. It might be car, it might be bike, it might be truck, it might be bus, anything you take.
Infotainment, sound system, air conditioning.
Perfect. So you have said some features now. Some said infotainment, some said safety, some said running conditions, smooth conditions. How all these have happened? How, in which part it has been evolved? It is nothing but a software part. When you see the percentage of software that is included in the current generation car, it is 80%. Right? It is 80%. 80% of the features works on software. Am I right? See, today you're talking about automatic cars. How does that happen? Driverless cars, automatic cars. What is the main key feature here? What is the main key driver here? It is software. Who is driving the car in driverless vehicle? It is software who is driving the vehicle. Am I right or not? Do you agree with me?
Yes.
Perfect. See, here the evolution of software has changed the shape of automotive industry. Correct. In the previous, I mean, when we take 80s and 90s generation of cars, hardly you will have like 10 to 15 ECUs. ECUs in the sense it is nothing but a control unit. Kind of one for CPU, for your entire PC, let's take CPU is your brain. Correct? Like that, there will be some ECUs in the car. I'll explain you what is ECU, what are the different types of ECUs in the later parts of the classes. But for the time being, for the knowledge, we have 10 to 15 ECU. One ECU will take care of one functionality. Let us take brakes ECU. Will take control of brakes. Engine ECU will take control of engine functionality like engine overheat, engine cooling, all these kind of things. Like that, for one purpose, there is one ECU dedicated. But when you take today's cars, as shown here, one basic car also will have 100 to 150 ECUs. Why there is an increase, a huge increase in the number of ECUs? It is because of the huge demand for the software features, huge demand for the safety features. Right? Safety features. Suppose if you talk about the safety features, let us take one safety feature. When the speed crosses 20 km/h, all the doors should be auto locked. All the doors of the car should be auto locked, even though we manually do it or not. Once the speed crosses 20 km/h, it should be auto locked. How does this happen? It is because of the software. Software will detect the speed. Speed sensors will detect at what speed the car is going. The sensor will give the information to the ECU, and ECU will lock all the doors. It is one safety feature. Airbags is one safety feature. There are so many other safety features like lane departure warning. You call it as an ADAS. I'll tell you what is ADAS also in the later classes. But what is ADAS? It is an advanced driver assistance system. You have cameras, 360-degree cameras, radars, sensors. All these are fitted. All these are introduced to enhance more like smooth driving experience and more safety as well into the vehicles. That is why today's, see, you take the recent release into the market, Mahindra BE6 and BE9. You all know those cars, right? Electric cars, Mahindra BE6, BE9, Batman edition. You know all this, right? Yes or no? Hello. You're able to hear me?
Yes, yes.
Yeah, your voice is audible.
Okay, fine. So when you take this Mahindra cars, what we're talking about, 90% of the car works on software. 90 to 92% of the car works on software. One software feature is missed without testing, entire car will get stopped. You see TVS two-wheelers, there is an app for TVS two-wheelers. So when you click on stop in the app button, your vehicle will stop, though it is running. You're driving a vehicle, you opened an app, and in the app, if you click on stop the vehicle, your vehicle will be stopped. That is the advancement of software we have achieved over the years. There are so many. We are talking today about driverless cars. We are talking about so many advancements today, all thanks to the software enhancements that has happened over the years. All thanks to the software developers and software test engineers who made this happen. That is why we are having the advanced vehicles all over the world. So our responsibility is to test the software whether it is working fine or not. There are so many methods to test it. What are those methods? How do we test it? Where do we get that requirements? Who should test it? How should test it? X, Y, Z, etc., etc., etc. All these questions from the scratch will be answered throughout your course. With every passing class, you will get answers to so many questions. Correct? Next. 4 pillars of embedded automotive testing. What are the different types of testing we do? First is unit testing, integration testing, hill. I'll explain you maybe about this in very detailed format in one of your classes where we talk about V model and where we talk about different types of testing. Okay. The standards that govern the industry. So there is this industry called as an automotive industry. For every industry, any industry you take, there will be some standards which will be set for that industry. Okay, in India, the vehicles should have this much height. The vehicles should have this much length. SUV should have this length. Sedan should have this length. Normal basic car should have this length. This many liter engine. This liter capacity engine. These should be the mandatory features. Camera should be the mandatory feature. So every country or every sector will have its own standards in the industry. So now today I'm establishing a car. I can't design a car on however I want. There will be some government standards or there will be some sector-wise standards which are set already, and every company has to follow those particular standards in when they are designing a new car or when they're releasing a new car into a vehicle. See, first one is ISO 26262. I'll explain you maybe detailedly, but for knowledge purpose, this is one standard which is used for functional safety for road vehicle, electric or electronic system. Functional safety in the sense, now we are all talking about this crash test, CAP ratings. Tata has secured 5-star, Mahindra has secured 4-star. This type of news we are hearing, right? What does this mean? Why do we do this crash test and why do we give rating according to that? Because it is to make the user confident on the vehicle. So this crash test includes so many things. They'll check so many. They'll not just crash your vehicle and then they'll give you 5-star, 4-star and all. There are so many checklists that will happen. What is the checklist? Whether all the functions are working as per the expectation or not, as per the industry standards or not, as per the Indian roads or not. So all these features will be checked. All the functions, all the safety features will be checked. Tata Harrier, they consider it as the most safety vehicle in the market. Why did they consider so? Volvo is considered as a safety market. Why did they consider so? Because it has the most advanced safety features. It might be in terms of the number of airbags. Some cars will have 2 airbags, some cars will have 6 airbags, some cars will have auto locking system, some cars will not have auto locking system, some cars have engine safety systems. There are so many. We will discuss all those things once we enter into the actual course. So all these features will be checked very thoroughly, very rigorously, and then only that particular rating will be given. Like that, we have many standards. AutoSAR is one standard. Or this is called A-Spice, Automotive Spice. This is for how software should be developed, how software should be tested. In the company, when one software is being, okay, I wanted to develop a software for infotainment. Okay, and then I have to test it. You cannot, okay, I'll write 10 lines of code, I'll give it to my tester, and then tester will test the 10 lines of code. No, that will not happen like that. There will be one process for that. First, you have to get the requirements clearly. What should be the infotainment system consist of? How does it should work? How does it should look like? All these things, first you have to analyze all the requirements clearly, and then you have to write a detailed software check. For that software itself, we follow this MISRA guidelines, coding guidelines that will eliminate risky and undefined behavior prone code. So when you go through this MISRA guidelines, all your default code will be fished out. So once it is fished out, you will give a proper code to the tester. Tester will test those in different levels of testing, and then only it will be released into the production. So there will be so many processes that will happen before giving that code to the production, or before releasing that software into the market. There will be lots of process and procedures which they'll be going through. We will learn about each and every process in a very detailed and a specific way. Okay, I think this is see here it is kind of walk through what happens, how you test it. First, you will define the test case. I mean, what should be tested exactly? Suppose if my vehicle speed greater than 0, the door lock ECU must auto lock within 500 milliseconds or within 1 second. Let's take, this is my requirement. When the vehicle speed is greater than 0, it means when the vehicle has started, the door lock ECU must auto lock within 500 milliseconds. This is just an example of a requirement. Okay. So first you have to test these scenarios. For that, you have to, if you are testing in an automation or if you are testing in a manual testing, whatever it is, you have to write the test case and then run the test, execute the test case on a particular hardware setup or a simulated setup. And then you have to analyze whether the software has been passing this test case or failing this test case. If the code is correct, your test case will pass. If the code is wrong, your test case will fail. So you have to analyze where it failed, whether I have tested it correctly or not, whether the software code has been correct or not. So after so much of analysis, you will define the test cases. But only when you approve that the test case is being passed, then only it will go into the production. Okay, this is a very important question. Why this skill is in high demand? You have so many things here. So when you, let's go back to the same example of 90s cars and 2000, the current generation. In 90s, you might have heard about like maybe 5-6 brands of cars, not more than that. Even though there are more brands, we might know only 5-6: Ambassador, Maruti, Mercedes-Benz. Only these kind of things you know. Correct? Do you agree with me? But now if you go on listing the cars, how many you can go and list the number of car companies here? You can list at least 25 to 30 or more, or even more than that. Yes or no? Yes or no? Anyone is there to answer in the class?
Yes.
Yes. So what roles you can expect after learning this course? What roles you can expect? Okay, I have done my course. what role I'm going to get in once I'm into job. There are different types of roles. First is embedded test engineer, where you will give some types of requirements for any embedded product. It might be car, it might be anything, any embedded product. You have to test that particular software behavior. Hill or cell test engineers, I'll tell you what is this Hill hardware in loop, software in loop test engineers. It is also related to this only, where you test this vehicle softwares and all those things. Validation and verification engineer, functional safety engineer, where if you master this ISO 26262 guidelines and testing, you will be hired as functional safety engineer. Test automation engineer, where you do the automation of the entire process. There is no manual testing needed. You automate the entire process, and then the features will be testing and will give you the end report. So these are all the different roles. Basically, the job you do is same. You get a software, you write test cases, and you test it. But in a different frameworks, in a different formats, all these roles will come up. Who will be hiring you? Who will be hiring you? What kind of companies will hire you? If you learn this course, what kind of companies will hire you? The first sector of companies is automotive OEMs. OEM, the full form of OEM is original equipment manufacturer. Original equipment manufacturer. It is nothing but a company which has its own product. Car manufacturers, let's take Mercedes-Benz, let's take BMW, let's take Tesla, let's take Maruti Suzuki, let's take Toyota, let's take Mahindra, let's take Tata, anything, Volkswagen, Skoda, any company which have its own product in the market, which has its own vehicle product in the market, we call them as OEMs. It might be two-wheeler, it might be four-wheeler, it might be six-wheeler, it might be 10-wheeler, whatever it is. And there are second type of companies called as tier 1 suppliers. Tier 1 suppliers. So why the suppliers work is, suppose if Mercedes-Benz want to release one car into the market in 2028, let's take. All the designing from the scratch, all the designing, hardware, procurement, software, development, testing, integration, all this will not be handled by Mercedes-Benz alone. If that is the case, Mercedes-Benz need at least 5-6 years to release one car, one model. What this Mercedes-Benz will give is, Mercedes-Benz is an OEM now. Okay, this OEM will give contracts to tier 1 suppliers like Robert Bosch, Continental, all service-based companies, Capgemini, Wipro, all service-based companies. What they'll give is, they'll give different tasks to this tier 1 suppliers. Okay, you get ready tire pressure monitoring system for me. You develop the software, test it and give it. And then they'll go to Continental and they'll ask you, you give me the software for my infotainment and get it tested. And then they'll go to Capgemini and then they'll give you like, okay, I'll give you the functionality of airbags. You develop the software and get it tested. So the client, this OEM will divide the work between different tier suppliers, tier 1 suppliers. And at the end, it will take all the tested softwares and then it will integrate into its vehicle. So you can get a job as a test engineer either in direct OEMs or either in the tier 1 suppliers. Perfect. And then semiconductor and chipset companies. This is little bit rare, but it is not impossible. When you have high knowledge, when your background is in ECE and you work more on the chips and all, because this ECUs which we are talking about will have this semiconductor and chips, intelligence chips. So there also you will have an opportunity if you have a background into electronics and you know about this automotive testing and automotive systems, how do they work and all those things. And then you have also now, as this EV market is uprising, as this EV market is also in demand, EV and autonomous driving startups, there are so many startups that are coming up with this EV. Like see, Ather is one startup and there is this one more, I forgot the name. There is this Magnus vehicle. This parent company, Ola, is one startup. There are so many startups in the EVs and autonomous drivings as well. So those startups also, you will have a huge scope if you know the testing, because a proper tester should be there. Once you wanted to test this autonomous driving, huge levels of testing should be done. So they need so many testers than developers. If there are 3 developers in the team, there will be 10 to 15 testers in the team, because development is easy in the automotive, not like in the other parts. But testing here is have a very, very high scope. Okay, all these companies, engineering services and consulting firms, like normal work-based, service-based companies like Capgemini, Wipro, and all these things. So all these companies will hire a automotive test engineers. What you will master in this course? What and all things you will learn in this course? First is foundations. What is embedded system? What is ECU? What is automotive network? Everything from the scratch, from the very basic. If you did not listen the word embedded automotive also till today, there will be no issue, because everything here will be dealt from the very, very scratch level. Even if you're a very newcomer to this field, it should all be okay. You will understand the things. That is how the course is designed. Next is test design. How you should understand the requirement, how you should write a test case for that, how you should test that. Everything will be taught from the scratch. Hill or sill, hands-on. I'll take my hill rig or my rig which I am working in current my company. So I'll give you the real-time project and make you run that project as well. I'll show you how to run that project and all those things. Standards and safety, I'll tell you about ISO 26262, ASPICE process and all this. MISRA is not needed for us because it is for developers. But this ISO 26262 and ASPICE is we will teach about it. Automation. So we will talk about two types of testing, manual and automation testing. So first is manual. We will check. We will learn how to do manual testing, and then we'll go for the automation testing using CAPL. CAPL is one language. And capstone project is like end-to-end test project, interview preparation, portfolio building, how to build your resume, how to approach for the interviewers, what are the skill sets you needed. Everything will be taught, and you will be taken mock interviews, like how the real interviews happen. And then you will be ready for a real-time interviews. So where this path can take you. First, you will complete this course where you will have the solid knowledge of embedded testing fundamentals and tools. And then you can go, if you're a fresher, you can go as a junior test engineer, where you will write and execute some simple test cases. If you're already working and you have an experience, you wanted to switch to the domain, you can directly go to the senior or lead engineer or hill or validation engineers. My current position is this hill or validation engineer. So where you will own the test setups, automation, where you will find defects, how do you solve that defects, and all those things you will take care of. And then progressively we can go for the senior or lead engineer. Okay. Now my part is done explaining, like, this is like just a brief demo on what is this course, what we are going to learn in this course, how this course happen, and all these things. Now it's your time to shoot with the questions, because being a new to any course, you might be, as a candidate, you might be having so many doubts in the mind. It might be very silly doubt as well, but no problem, you can ask.
How many days the classes will be held?
30 days.
It's daily or weekend?
Yeah, daily.
Timings?
Daily evening 1 hour will be there. Basically 30 hours of classes.
Overall per year.
Yes.
Do we
yes.
have any weekend batches?
Weekends also we take classes, but especially weekend batches we don't have. Maybe if everyone opts for only weekends, maybe we can take that as well.
Okay, no, actually, I have taken career break, so I'm restarting. So I have kids and everything. So On
Understood.
weekdays, it is difficult for me
Okay, fine.
to manage it.
Maybe
So,
based on the majority of the students,
okay,
we will decide whether it is like daily classes or weekend batches. But one advantage you will have is you will have the recordings of the classes, and any
okay,
time in the weekends you can join. If you have any doubts in the recordings, you listen and all. In the weekends you can join and get those doubts clarified if you don't understand some concept or something like that, if it is
okay,
not weekend batches. I'm just telling the last option.
okay, okay. So, okay, actually, I'm from embedded background only. I've completed my master in embedded, but I have not joined job. Just it
Okay.
was like 1 year of contract period only.
Hmm.
So it is like manual testing only, board level testing only I did.
Okay,
So
perfect.
how can this opportunity be helpful for me? So when I start this course, and how will this be useful for me to join a job?
Good
So
question.
to starting.
So here, as you have already knowledge on embedded system, it will be a kind of added advantage
Actually,
for you.
5 years of breaks, I'm
How many
completely
years of break
new
you
now.
have? Sorry?
6 years, 6 to
6
7
years.
years.
Not a very
Yeah.
big deal, okay? So as you have knowledge on embedded systems already, so what this course will help you is like, it will, first point, it will help you brush the concepts you already know. What is embedded system, how does they work, and how does they operate in the real world systems, and all those things. And in addition to the brushing of already known concepts, you will learn so many new concepts like hill testing, sill testing, regression testing, integration testing, bugs. What is the the current world trends that are happening, what type of tools we use, how does we test it, all those things you will be testing it. This course will be like, it will be very close to the real time work what we do in the office. It is
Okay.
like ready made course. Okay, you go into the office, you know all the things what to do.
Okay.
That's how the course is designed. Maybe this
So
will
for me,
help
what
you
kind of
in.
opportunities?
Sorry.
Because since long break, I'm totally new to it.
Hmm.
So how this opportunity will be for me? So can I get if I'll be able to get job or like that? I'm asking.
I think yes. See, there are so many companies which runs this program for a woman with a career break.
Okay.
Every year
So
this career break programs will run. This is targeted especially to hire a woman with career break, and this is
okay.
more in this automotive testing field. This automotive testing
Okay.
field have more these kind of programs. I think
Okay.
even though normal companies also will hire you if you have a good
Mhm.
knowledge on it, but no, if you like, if you're hired by normal company, one point is like, you should start with little bit less salary than the experienced people. That's all.
Okay. Okay.
Because you have 6 years of gap and you're now starting it afresh, that is also not problem. But okay, maybe the expected salary for you might not reach. Maybe you should start with a
Okay.
low salary. Maybe you can work for 1 year and then switch it to the higher salary. That is the only thing.
Oh, okay. 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 In this field, there is opportunities are there. Okay.
Yes, yes, yes.
You give assistance for that also.
I can refer if there are some openings. If I know, like, there are so many companies which I know. Maybe if in those companies, if I get some referrals or things, I can share it with you. You or
Okay.
else you can directly upload your resume in the Naukri. Recruiters only
Okay.
will contact you
Okay. Okay.
if they have that opportunity and all.
Okay.
After completion of this course, if we get any support on interviews or job support is there?
Job support, it depends. Suppose if you're going to office and all, maybe the support will be minimal. If you're work from home, that's fine. But interview support will be there 100%. If you wanted to give interviews on your own but need tips or but need support on the back end, that is all be given 100%. The only thing is you have to learn it 100%, whatever it is taught in the course. You have to be confident enough in this week. But still, if you need some support, we will always be there. We will give you the interview support for sure. If you schedule an interview, It can be any type of support, whatever you wanted. However you want the support to be, it can be given. Work support also, if you have some project, if you are entering into the project and you need some support in the test case writing, or you need some support in the execution, that support can be given.
Why in this course we learn something now?
Yes.
The same thing we applied in our projects, or any difference in this day?
Same.
Like,
I'll make you learn 2 projects which I have done in my career only. There is nothing called like, okay, we'll take one sample project and teach you. No. It is a real-time project only, what we are going to learn.
yeah, I understand. It's basically if you work on, I think you said you're working on HIL. When we entered into our project, if they give on ADAS or tire pressure monitoring, hill
See,
climbing.
any ECU is fine. Any ECU is same. The testing process is same. If you are confident on the process of testing, ECU is not at all a matter. See, I worked on infotainment, ADAS, and tire pressure monitoring system. Now, if I go to the other company, they might give me the brakes ECU, which I don't have any experience into. But the testing process remains the same. Only the requirements will change. Okay, after going, I have to understand my new requirements and then continue with my testing process. That's all. You got answer for the question, or did I have some misunderstanding?
Yeah.
Okay. Any other questions?
For a beginner, surviving in this industry is okay, or any hard difference?
Okay, let me be honest here. For any level of engineer, this is the safest thing. See, whenever you compare the courses in the market, you will have so many courses, right? Java, Python, XYZ, Microsoft Cloud, Azure, AWS, so many courses are there. But I promise you, this will be the easiest course you can ever learn, and this will be the easiest thing you will ever survive on. Because there will be no much tools, no much protocols you need to learn. All you have to learn is one tool. Okay. If you're confident in that one tool, you can survive in any company, because all the companies will use that tool only for this automotive testing. You need not learn so much to survive here. You're confident on basics, your survival is safe.
If AI shows any impact on our work?
Okay, this is one more important question. See, as this is blend with hardware and software, both, see, you are testing one software in your setup, which consists of both hardware and software. So AI doesn't have much impact. Maybe one area where AI can impact is writing test cases. Normally, before AI, if the requirement is given, let's take the same requirement what we have studied here. Where is it? This one. When the software fails at 100 km/h, or like when the car speed is greater than 0. Let's take the same requirement. Before, what it is like, if you are given the requirement like this, only engineers should write a test case for that. Okay. Only engineers should understand the requirement and test all the possible scenarios. What if it is greater than 0? What if it is less than 0? What if it is equal to 0? So engineers should be skilled enough to derive all the test scenarios. But now with AI comes, you give the requirement to AI. AI will draft you the test cases. That is the only area where it is affected. Okay. But the actual testing, execution in the hardware, AI cannot even touch in the future years. At least for the next 10 to 15 years, it cannot touch. Because it is like direct interaction with the hardware where AI cannot do anything. If you comes to the development, AI can replace everything. Because if you give the requirement, AI can write the code. But for testing, it cannot do. At least for the next 10 to 15 years, I am not foreseeing any AI impact in this particular testing, only except for the writing of test cases. Okay, I'll give you a real-time example of this AI as well. Recently, we have one issue with the testing of some internal signals. We call them internal signals. Let's forget what are those internal signals, just to understand the scenario. We tried deploying one AI agent to test that internal signals. We created that agent and then we tried it. But it did not understand the mnemonics of the hardware inside, where this signal goes, how that hardware process it, and all those things. It did not understand. It just understood, okay, if the signal is given, the following action should be done. But it failed to understand the mnemonics of the internal hardware. So the entire agent was malfunctioning. So it is not very easy to for AI to replace this hill testing or whatever, this embedded automotive testing field as of now. If you give testing of Amazon website, AI can easily do it. But I don't think so. With the hardware, it is not replaceable at least.
Okay, in this course, actually, we need to know about the hardware also. Yes.
Yes. Tell me.
In this course, no, ma'am, actually, we need to be knowing about the basics of hardware and everything.
Nothing.
Is it very much required or?
Nothing. See, we we all like, see, okay, the combination of hardware and software only. You will learn everything in the course. ECU. I'll connect the ECU and test it. That's all. Electronic control unit. That's all. Suppose, let us assume you are testing a mobile phone. Okay. You need to know
Okay.
about the mobile. That's all.
Mhm. Okay. No, when companies, when they are hiring, they actually will it be a thing that they should really know about the hardware, what is running
Nothing.
with the
Maybe
microcontrollers
you
and
will get
everything?
more clarity on this once you get to know about this ECUs concept.
Okay.
I don't think that is a very big challenge as well. Even today, even till today, I don't know anything about hardware first. I know only about my ECU, which I am testing. That's all.
Okay. 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 In this course, that is all that will be covered. ECUs,
Yes, that will
everything.
be covered. Yes, that will be covered.
Okay. Okay.
Any other questions? Okay, if we don't have any questions, maybe we can wrap it up for today.